Algebra 2, we're looking at lesson 10.9, and the big idea is finding areas of triangles. And very often we might have to use trigonometry to do that. So take a look at what we have in the notes right here. For a right triangle, the legs are perpendicular and they form the base and the height of the triangle. So if you were to have this triangle right here, obviously we think of this as our base, this as our height. But of course, we can rotate things. We can turn them around. We can, turn this triangle so that would look like so. So just because the base is not where we might look at on the floor, we can definitely rotate the triangle back if we started this way. The reason why I'm bringing that up is take a look at example 1. We have this right angle here. This is guaranteeing that we can measure a height, and we can call this our base right here. We could call this our height. I'm going to call this height x. We don't seem to know what that is. They want us to find the area of this triangle, and you can see up on the top right here, the formula for the area of a triangle is plain and simply 1/2 base times height. So the problem is we don't know what the height is. So we can use trig to help us get there. So from this reference angle, this acute angle of 42 degrees, I can draw across this way and say this is my opposite side. This right here would be my adjacent side, and of course we're going to go back to SOHCAHTOA. Even this week, as we're venturing into our third part of trig, the third component of this unit, we're still using SOHCAHTOA, and we have opposite and adjacent. Well, I hope at this point we can think of this as tangent, and we can have the tangent of 42 degrees is equal to, well, opposite would be 13, and adjacent would be x. So it's at this point, or if you think back to what we've been doing, we would cross multiply, and we'd get x times the tangent of 42 degrees, and 1 times 13 is 13. I'd like to get x alone. X is being multiplied to the tangent of 42, so I will divide by the tangent of 42. Now it's here that we're going to do something differently. You see, in the past, we would take out our calculator right now and we'd work this out and get a decimal approximation for x. The problem is, look at these directions. Do not round any intermediate computations. That's what x is. That's not your final answer. You're trying to get the area of the triangle. The area of the triangle is 1/2 times the base times the height. So you know what we're going to do, guys, is we're just going to keep the height, this x value, as it's written, 13 over the tangent of 42. So the base we said is 13. Our height would be 13 over tangent of 42. And guys, if you just work that out, then you'll be good to go. Otherwise, you make a possibility of having a round off error. You don't want that to happen. Notice I'm checking that I am on degrees. That's always important. I'm just going to type out 1/2. And by the way, you are more than welcome to use your fraction button right here. 1/2 times the 13 times, and you can get another fraction up here. Say it's 13 over the tangent of 42. By the way, Alex has this built in anyway. You can just use the calculator on the Alex screen. Looks like we'll get 93.8, and that is what we're going to type in for our area. Okay, so that's example 1. For example 2, you're going to see that the big difference is that we are leaving the world of right triangles. You can now have triangles that have all acute angles or an obtuse angle, a big angle. But if you have an included angle in two sides, like for example, if we had triangle ABC right here, if I give you angle A, if I give you side B, and if I give you side C, and if you have what's going to look like almost like a side angle side pattern where that side is right in between, then you may do this formula. The area is 1/2 the two sides multiplied together, and you multiply by the sine of that angle. So take a look at this right here. I've got my A is here, my B is over here. We could call this my C. As long as this angle is between those two sides, you're going to be able to work out this area very quickly. So I'm going to have 1/2 times 11 times 9 times the sine of 153 degrees. So we'll just get our calculator out and get this typed in. Say here's 1/2, here's 1/2. We'll say times 11 times 9 times the sine of 153 degrees. And it looks like we'll get 22.5 because the 4 is next to the 7 here, so we've got to bump it up. 22.5, we're done. So you won't always see an obtuse angle inside of the triangle. If you do, it really doesn't matter. The last problem that we're going to take a look at actually doesn't use trigonometry, but it's a wonderful formula. It's called Heron's formula. And for any triangle where you know all three sides, sides A, B, and C, the area is, well, if you find the semi-perimeter means add up all three sides and divide by 2. Semi always means 2. And then you'll be able to work out the area of that triangle by taking the square root of s times s minus a, s minus b, and s minus c. So let's very quickly just label our three sides. This is only when you know all three sides are given to you. And we could very quickly say, well, what's s? What's your semi-perimeter? Well, it's your three sides added up. Divide that by 2. So we could do that pretty quickly. You can even do it in 2 stages. You can go 14 plus 10 plus 15. You know, adding those up, you could see very quickly the top is 39. I like to get a decimal, honestly. That's why I didn't use the fraction button. Your fraction would have been 39/2, but that's 19.5. Now the area is the square root of s times s minus a, s minus b, s minus c. You know what s is now. It's 19.5. So it's 19.5. 19.5 minus your first side of 14 times 19.5 minus 10, and then finally 19.5 minus 15. You don't even have to do any subtracting. You could just let the calculator do all the work for you, thank goodness. So I'll get my square root out. I'll go 19.5 parentheses 19.5 minus 14. Close that, make a new parenthesis. 19.5 minus 10. Close that parenthesis, one last one. 19.5 minus 15. Close your parenthesis here. Just hit enter and you'll get your area, 67.7. And that's all you got to do, and that's Heron's formula.